Hello all, in this video we'll be talking about different types of switching. Okay, now this I have explained in the class also. So we'll just quickly see the definition of the different types of switching and how it works. All right. So switching is basically we have seen the structure of the telephone system, and then we have seen the toll office. Okay. So let me show you this diagram. We have the end office, toll office. Okay. So from the connection that is made from the telephone, it will go to the end office and proper path is selected, and from it goes to the higher office, that is toll office. So that switching has to happen. It has to do the connection with that number line which is there in the connection. Okay, so it has to choose that line, do the connection. Okay, so that is switching. All right, how to choose from the different lines the line that is there in the required in the connection. All right, so that happens here. All right, in the switching. All right, now there are two ways in which we can do switching. The first one, okay, is the circuit switching, and it was used initially in the telephone system. We have seen those toll office and all that offices, trunk office, all that. So these are your different offices. Okay, and they have see, these are the nodes. All right, these are your input and output. All right, so when you have to actually connect the switching, so you have to select that dot and select it to the other dot. Okay, so that is why that number of dots are there, so that you can, depending on which dot has to be chosen, that connection can be established. All right, so what happens is that the switching equipment within the telephone system seeks out a physical path all the way from your telephone to this telephone. So our path has to be selected, depends on which node will be activated, which particular point will be activated inside the different office. And then once all the nodes, like see in the dots, okay, all the nodes are connected, then we can say that the physical, now here the very important term is physical connection will be established and the call will be made. So this here is called circuit switching. Okay, so next is your packet switching. You just have a look here. This is the diagram. Okay, so here proper path is not there, proper established path is not there, but it is in the term of packets. Okay, that it has to be sent across. Okay, we'll come back to it. So here let's look at the definition first. Okay, we have the second category also, which is called the message switching. All right, so in message switching, all right, so what happens in circuit, going back to circuit, what happens, the circuit has to be established, and then the data will flow. Okay, data will stream in. Okay, one data will flow, then the stream of data will go, okay, bit by bit. Whereas in message switching is slightly different. Okay, there first of all we don't have to establish the connection. uh, okay, so the path need not be established, it will not be established. One message will be formed, a packet of data will be formed, and then it will hop from different offices. Let's say this is one office, then different office. Okay, the same diagram you can utilize. All right, so a message will be there. All right, that message will hop, it will hop from one office to another. A fixed path will not be there. If you see that this office is busy, these paths are busy, then it will go to the next one. Okay, instead of going here, it will take the next path depending on the congestion, and then it will go. So no fixed path is there. Okay, depend on whichever traffic is available, the message in its entirety. Okay, so it's 8 bit or 8 byte or whatever. Okay, so the whole bit has to first come in and stay in one office. Then when it stays for whole, then it will go to the next office. Okay, I hope you remember what I explained in the class. So in its entirety it will flow. So that is called message switching. The problem with message switching is the size. Okay, the size of the packet, the size of the message. If it is very huge, then it will take a lot of time to come in and stay in one office. So it will take time to buffer in. The whole thing has to come in that office, and then it has to go from one office to another. So because of this no limit on this block size, it created problem. Okay, it created problem because long time was required to buffer. Okay, then it will keep the office busy, too busy when they are doing the transfer. It will keep it busy because the size is very huge. So it also means that single block can tie up, keep it busy from one router to another line for minutes. Okay, and then sending across and taking back will be a problem, will be quite time consuming, okay, because of the message size. Okay, and for interactive traffic, this I had explained that if you have to send and take data at the same time, interactive, I'm saying hello, you are saying hi, but if your hi is saying hello a lot of times, then I will not be interested. So such kind of message switching is not useful for interactive traffic because of the size of the message. So that is why it came the next one, in which your the size of message is decreased into smaller units, okay, which will not take a lot of time to flow across, and that is called packet switching. And what you see here is actually the diagram of packets. Different packets, tiny packets, okay, messages are comparatively larger. Okay, so packets are going in. Okay, again here fixed connection is not there. Okay, packet connection established. See, this connection is not established. It will go as on the spot. Okay, on the spot, whichever traffic is there, it can take either this. If you see that this is fill, okay, this is congested, then it will take up this. So again, going in here, then any path it can take, its main job is to reach here. So the paths are not fixed depending on congestion. If it can follow any, so it's flexible like that, the route is flexible. So that happens in packet switching, and it is very good in interactive traffic because the size is small. See, packet switching and networks are very good in handling uh, interactive traffic. Okay, and further advantage is because it is tiny, so one packet has come, you can take it forward. You don't have to wait for the whole set of packets to come in, like in the case of message, the whole message has to come in. So if the message is huge, you have to wait for the whole message to come in. Okay, so that doesn't happen in packet. Okay, because of the tiny size, one packet will quickly come in and then you will send it across. Okay, so that waiting period is not there. All right, so that is another advantage, reducing delay and improving throughput. Okay, so you can just take it forward as the packets come in. So it is very good for fast traffic, for your interactive traffic. So these are the three different types of switching, and let's see the diagram. This again we have seen in the class. Let's quickly see it again. So, and as I told you, in circuit switching, physical connection has to be established. So this whole part is doing that. Okay, you have from one your sender to the receiver, the establishment of connection has to happen. So that is with the request signal, it will go. Okay, it will take some time to flow across and go to the sender. Okay, so this is the time it takes from A to B, from the different offices. From A it will goes to B office, B to C, this switching office it will go. And once the call accept signal has been sent back, then only your actual data will flow. See, the whole set of data is flowing in via the different switching office, the trunks. Okay, so that happens in circuits. Once the connection is established, then the data flows. Whereas in message and packet, you will not see the first half because there is no establishment of path step here. Okay, straight away the message is sent. So a whole message, see the size is huge, so it's sent. So it will take some time for that message to come in its entirety. So that will take some time, and that will be the propagation delay. So once it reaches an office, then it is stored forward. So again some time will be utilized, to go one message, a whole message to come in. Then again, if the office is already having a message, so it will wait for some time for that message to get rid of the previous message and start taking the new message. So that is called your queuing delay. So a lot of delays happening because of the size, okay, from one office to another in case of message switching. Whereas look at packet switching, you are not waiting for the whole message to come in. It is small tiny packets. Okay, so it's one packet, and packet 1 goes across, okay, before packet 3 has come. See, packet 1 has reached here. All right, before packet 3 has come in the first office. So that way it becomes very fast. You are not waiting for the entire packets to come in, entire series of packets. Okay, so that way it is very suitable. So here also see packet 3 has not come in properly. Packet 1 has already reached the next office. All right, so that is the different types of switching that we have, and we have seen this in the class also. So I hope you have understood. And so let us quickly look at the differences. Okay, so the difference we have seen here. Okay, let's look at this one is explained in the last class. Let's quickly see here, packet switching, the first kind of switching. All right, the first I think this is physical connection. Yeah, this is the packet switching one. The connection is established. Every time you see packet switching, you'll See this physical connection. Okay, so packet switching uses, oh sorry, this is not physical packet, sorry, this is your circuit switching. All right, so this is circuit switching. What I want to show, yeah, this is also circuit switching. All right, so see the lines are established first. Where is my packet? Okay, this is my packet. Okay, so it can take any route. First it can take this, second time it can take this. All right, so here what happens is that store and forward, this also explained that even if it is a tiny packet, okay, if I'm talking of packet 1, that packet 1 has to come in, it will be stored and then it will hop. Okay, same like your message, the whole message is to come and then only hop. And then packets also, the whole message, packet 1 has to come. I'll show you the diagram. The whole packet has to come and then it will hop. Okay, so that is called store and forward. First you store it and forward it. Similar in the case of message also, the whole message is to come, store and forward. Applicable for these two. Okay, store and forward transmission. A packet is accumulated in router's memory, that office memory, and then sent to the next router. With circuit switching, whereas in circuit switching, this one here, circuit switching, the bits just flow, it streams, okay, bit by bit it streams, it does not wait. If one bit is there, it will go through the wire continuously. Okay, now the storing, if we are storing, waiting, then it will cause little amount. In packets it is smaller, in message it is more, but then the delay is there because you are waiting for the packet or the message. Okay, so that is one difference. That is another difference between packet and your circuit switching. Okay, another difference is that circuit switching is completely transparent. The sender and the receiver can use any bit rate or framing method. Now I'll quickly explain you. Once the line is established in circuit switching, it is the, like here, line is established, then you have to understand that, okay, I will send bit in this is my speed, okay, let's say 6 bits per second. So this has to understand, so they will agree on a rate, they will agree on a format. This is the format that I am sending. Okay, first this many bits is start bit, end bit, so they will agree on a particular format, particular rule in case of packet switching, and the speed also has to match. Okay, so that happens in circuit switching. Whereas in your packet switching, with packet switching, the carrier determines the basic parameters. Okay, it is just the connection, both has to be there, and then not too much discussion will take place between the, how much I will send, what will be my speed. Okay, because the path is not fixed. All right, it is not directly connected, so they can follow just the basic thing has to match, and then they can start sending the data from here or anywhere. Okay, so that is another difference, just like your road or rail. So this is your road because proper the size and all that has to happen, but in railroad, different types of carriers are there. Okay, and it is allowed. So like that, the flexibility is there in case of packet or message. The final difference, let's see, the final difference is the charging algorithm. Now charging means how much money. So earlier telephone system, it was the wire. Okay, so the more you talk, the more you pay, and then the more the distance, the higher is the payment. So that depend on, it used to depend on distance and time, our earlier telephone system. But in case of your packet and message, okay, though the charging is there, okay, if you could do multinational calls, then the charging is there, but then it does not depend too much on distance and time. That is another important difference. Okay, so let us quickly see now the difference that is there in the book. Okay, now this difference is also very important. They will ask you what is this and this switching and what are the differences. Okay, quickly see, this is the circuit switching. Circuit means a whole connection has to be established. See this green line, dedicated connection. Once it is connected, no one else can come in between. Whereas in case of packet switching or message, it is any router can be selected. It can be this, or it can be this or anything. Okay, so let's look at the difference. Call setup required, physical path is required. In packet, it's not needed. Dedicated physical path, yes, it is required. No. Each packet follows the same route. Yes, because one line. So it has to follow the same route. But as I told you, depending on congestion, it can pick up any route. Packets arrive in order. Yes. Here it is not arriving in order. If the first one is going first and it is following the next path, then it may reach first. So later it will be checked. Okay. But it does not follow a particular order. Is a switch crash fatal? So if the line breaks, if the line is breaking, then no one can help. Gone. The connection is gone. But in case of this, if this line is breaking, then we can make use of another line. Okay, so it is not fatal. Bandwidth is available, it's fixed in that wire. Whatever is bandwidth, that is fixed, it will not change. But dynamic, okay, depending on how many lines you are using. When can congestion occur? At setup time. Okay, if it is already busy, then you can say that it is already busy, okay, in the starting time. But once the connection is established, you don't have to worry about the congestion. Okay, but in case of packet switch, every packet is a new packet, so you have to see whether this is fill or not, the path is fill or not. So next, same tension again, next path is fill or not. So for every packet you have to worry about the congestion, but congestion worry only in the starting. Once it is established, no more congestion worry. Okay, so once the line is utilized, even if you don't talk, even if you don't send any data, you are actually utilizing the line. Okay, so you are wasting the bandwidth. So if the packet is not, data is not flowing, then it can be used for some other transfer, so that way bandwidth is not wasted. Store and forward, we don't store it here, it streams, whereas in this case message and packets are stored and forwarded. Transparency, yes, in case of circuit switch, we see how, what is the distance, what is the time, all that, whereas in case of packet switch it is not there. Charging is per minute, and here it is charging per packet. So this is the difference between your circuit switch and packet switching. I hope it is clear. Okay class, please listen to the video carefully. Bye bye.